Channel. So in this tutorial we are going to look at this integral from 0 to 1 of x squared cosine of 3 natural log of x dx. So let's solve this integral. Before we do that, we want to make sure you're supporting my channel by hitting the subscribe button for more engaging and challenging tutorials on integral calculus. So let's solve this integral. So I will first start off by using an identity which is very popular. Call it the Euler's identity. So we are going to use the Euler's identity, which states that E to the I of theta is equals to cosine of theta plus I sine of theta. We know that the real part of this EI to the theta is the cosine of theta, and the imaginary part of EI to the theta is the sine of theta. So here, if we have cosine of 3 natural log of x, then this one, using the Euler's identity, cosine of 3 natural log of x is going to be the real part of this is now theta. So it's going to be ei 3 natural log of x, or you can say 3i. E3i natural log of x, because this one is now our theta. And we can use the laws of logarithm. So this becomes the real part of e to the natural logarithm of x raised to the power 3i. And that is just the real part of x to the 3i. Because this and this will sort of like cancel. So we can plug that back into our integral. So instead of writing this, we can now write this, which is the real part of x to the 3i. So our integral now becomes integral from 0 to 1 of x squared times the real part of x raised to the power 3i. So dx, sorry about that. So this one becomes integral from 0 to 1 of x squared. Okay, we can have the real part of x squared multiplied by x to the power 3i dx. But this one simplified to integral from 0 to 1 of the real part of x to the 2 plus 3i dx. So in the end, we can substitute, or we can exchange this one and the integral. So it becomes the real part of the integral from 0 to 1 of x to 2 plus 3i dx. And this one we are just using the power rule here. So this one becomes the real part of, using the power rule, x to add 1 to the power and divide by the new power. This one, the real part of x to the 3 plus 3i all over 3 plus 3i. So we are done with our integration. We just have to now take the real part of this. But how do you take the real part of something like this? We have to rationalize the denominator to see whether we can isolate the real part from the imaginary part. So let's do that. So we have the real part of this one, x to the 3i plus, I'm sorry about that, I have to take the limit from 0 to 1. Didn't take that all along. So that is from 0 to 1, 0 to 1, limit from 0 to 1. And now we erase this. So if you plug in 1 x to be 1, you are going to get, this is just going to be 1 all over 3 plus 3i. R minus 0, plug in 0, everything is 0. So you're left with the real part of 1 over 3 plus 3i. At this point, we can now rationalize our denominator. So RE is going to be 1 over 3 plus 3i and multiply by 3 minus 3i over 3 minus 3i. That is by taking the conjugate of the complex number. So that's going to be the real part of 3 minus 3i all over. This is like difference of two squares. So that is 3 squared minus 3i squared. So 3 squared minus 3i squared. 3i squared is positive 9. So we have the real part of 3 minus 3i all over. This is like 9 plus 9, which is 18. So we can now isolate the real part from the imaginary part. So you have 3 over 18 minus 3i over 18. And that simplifies to the real part of 1 over 6 minus 1 over 6i. So we are just taking the real part of this complex number, and the real part is 1 over 6. So this is equals to 1 over 6. So in that case, if we solve this integral, that is the integral, what was it? X squared cosine of 3 natural log of x squared cosine 3 natural log of x integrating from 0 to 1 dx. That is going to evaluate to 1 over 6. That is the real part of this complex number. So if we evaluate this integral, we are going to get 1 over 6. So that's it. If you find this video helpful, make sure to hit the subscribe button for more engaging tutorials on integrals. I thank you so much for watching the video, and I will see you in the next one. Bye bye.